Bismillahirrahmanirrahim. Assalamu alaikum dear students. This is Cambridge Physics 5054 course and I'm your teacher Maryam Rafiqu. Today we're gonna discuss chapter number 17, that is static electricity. The study of electrostatics has proven useful in many areas, and this lecture covers just a few of the many applications of electrostatics. Here are some learning outcomes like Van de Graaff generator, photocopier, laser printer, inkjet printer and electrostatic painting, smoke precipitators, and some assignment questions. Now what is Van de Graaff generator? A Van de Graaff generator is an electrostatic generator which uses a moving belt to accumulate electric charge on a hollow metal globe on the top of an insulated column, creating very high electric potentials, and it produces very high voltage direct current electricity at low current levels. Van de Graaff generators are not only spectacular devices used to demonstrate high voltage due to static electricity, they are also used for serious research. The first was built by Robert Van de Graaff in 1931 based on original suggestions by Lord Kelvin for use in nuclear physics researches. Van de Graaffs use both smooth and pointed surfaces and conductors and insulators to generate large static charges and hence large voltages. Students, you can see that a very large excess charge can be deposited on the sphere because it moves quickly to the outer surface. Practical limits arises because the large electric fields polarize and eventually ionize surrounding materials, creating free charges that neutralize excess charge or allow it to escape. Nevertheless, voltages of 15 million volts are well within practical limits. Here you can see the schematic diagram of Van de Graaff generator. A battery A supplies excess positive charge to a pointed conductor, the points of which spray the charge onto a moving insulating belt near the bottom. The pointed conductor B on top in the large sphere picks up the charge, that is the induced electric field at the points, is so large that it removes the charge from the belt. And this can be done because the charge does not remain inside the conducting sphere but moves it outside surface. So an ion source inside the sphere produces positive ions which are accelerated away from the positive sphere to high velocities. Now we have to see the xerographic machine using drum photo receptor and biased rolls. Most copy machines use an electrostatic process called xerography and a word coined from the Greek words xeros for dry and graphos for writing. So the heart of the process is shown in simplified form in figure, you can see here. Now students, observe that a selenium coated aluminium drum is sprayed with positive charge from points on a device called a corotron. Selenium is substance with an interesting property. You can say that it is a photoconductor. And that is, the selenium is an insulator when in the dark and a conductor when exposed to light. So this is the property of a photoconductor. Now you can see students that in the first stage of xerography process, the conducting aluminium drum is grounded so that a negative charge is induced under the thin layer of uniformly positive charged selenium. While in the second stage, the surface of the drum is exposed to the image of whatever is to be copied. So in locations where the image is light, the selenium becomes conducting and the positive charge is neutralized. So in dark areas, the positive charge remains, so the image has been transferred to the drum. And in the third stage, takes a dry black powder called toner and sprays it with a negative charge so that it is attracted to a positive regions of the drum. Next, you can see that a blank piece of paper is given a greater positive charge than on the drum, so that it will pull the toner from the drum. And finally, students, the paper and electrostatically held toner are passed through heated pressure rollers, which melt and permanently adhere the toner to the fibers of the paper. Now students, here is another application of electrostatics, that is laser printers. Laser printers use the xerographic process to make high quality images on paper, employing a laser to produce an image on the photoconducting drum, as you can see here in figure. In its most common application, the laser printer receives output from a computer and it can achieve high quality output because of the precision with which laser light can be controlled. So many laser printers do significant information processing, such as making sophisticated letters or fonts, and in the past may have contained a computer more powerful than one giving them the raw data to be printed. Now here are some advantages and disadvantages of the printers. Advantages are like this is inexpensive, not easily damaged, simple to use and fast. And some are the disadvantages, like a card can be copied fairly easily and sensitive to strong magnetic fields. Okay students, now here is inkjet printers, and inkjet printing is a type of computer printing that recreates a digital image by propelling droplets of ink onto paper and plastic substrates. So inkjet printers are the most commonly used type of printers and range from small inexpensive consumer models to expensive professional machines. Students, the inkjet printer commonly used to print computer generated text and graphics and also employs electrostatics. You can see here in this schematic diagram that a nozzle makes a fine spray of teeny ink droplets, which are then given an electrostatic charge. So once charged, the droplets can be directed using pairs of charge plates with great precision to form letters and images on paper. So inkjet printers can produce color images by using a black jet and 3 other jets with primary colors, usually cyan, magenta, and yellow. Much as color television produces color, so this is more difficult with xerography requiring multiple drums and toners. Now there are some advantages of inkjet printers, like the color is perfect, it is faster, the dot matrix, daisy wheel, and laser printers. And most models are relatively lightweight and compact, so they don't take up too much space on the desk. Now we have to see the smoke precipitators. A smoke precipitator or an electrostatic precipitator is a device which removes smoke or other particles from the air using high voltages electrostatics. Students, this is also another important application of electrostatics that is found in air cleanser, both large and small. And the electrostatic part of the process places excess, usually positive, charge on smoke, dust, pollen, and other particles in the air, and then passes the air through an oppositely charged grid that attracts and retains the charged particles. You can see that a large electrostatic precipitators are used industrially to remove over 99% of the particles from stack gas emissions associated with the burning of coal and oil. And also the home precipitators, often in conjunction with the home heating and air conditioning systems, are very effective in removing polluting particles, irritants, and allergens. Here you can see the schematic diagram of an electrostatic precipitator. Air is passed through grids of opposite charge. The first grid charge airborne particles, while the second attracts and collects them. In B, you can see that the dramatic effect of the electrostatic precipitators is seen by the absence of smoke from this power plant. In the last row, you have to see the spray painting. The two most common methods for applying electrostatic paint are: number one, a negative charge is applied to the paint while it's in the reservoir, and the second is a charge is applied in the barrel of spray paint gun. As the paint is propelled through the gun, it rubs against the side of the nozzle and gains a negative electric charge. So for electrostatic paint to be applied, the vehicle needs to be grounded and positively charged, and this creates a magnetic attraction to the negatively charged paint. And due to this charge, when the paint leaves the nozzle, it is attracted to the vehicle's charge and will stick to it. Now, there are several benefits of using electrostatic coatings, like makes a stronger bond to cover an object more evenly, even if the vehicle has many angles. This method saves paint by ensuring more paint lands on the charged vehicle than the surfaces around the vehicle, creates a better looking finish because the paint is distributed more uniformly. I hope that you understand all these, and now this is the time for assignment, students. Here is a question you have to solve. Like, one method of painting a metal panel uses electrostatic charges. A paint spray produces paint droplets, all of which are given a positive charge. The metal panel is given a negative charge as shown in figure 8.1. Now what you have to find, students, in A part you have to state the effect that the charges have on each other. Number 1, like charges. Number 2, unlike charges. And in B part, you have to explain that why the droplets spread out as they leave the nozzle in figure 8.1. And also you have to explain that why it is important that the metal panel has a negative charges. While in C part, you have to state one advantage of using electrostatics in this way to paint the metal panel. So you have to solve this question, and after solving you have to see the another question here, that a figure 5.1 shows you the boiler of a coal-fired power station. So hot gases rise and thermal energy warms the water inside the metal pipes. So what you have to find actually here in figure 5.2, you have to show an electrostatic precipitator that stops dust and ash emerging from the chimney. So you have to explain how the precipitator works. Thank you so much and good luck.